Hello everyone, welcome to the next class on the MATLAB programming. Today we will discuss about the transportation problem, how to design the MATLAB code of the northwest corner method. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You all feel free to contact me by either of my email ID. So we will firstly go through very briefly what about the transportation problem and what are the basic features that will help us to design the MATLAB code. So in general, the transportation problem is right in this matrix format in which supply and demands are there. O are my sources which are and the number of the goods are transferred from the OIs to the destination DJ, and the cost which transform from the O1 to the D1 is representing as C11. This is the supply required by the OI and this is the demand by the D1 and so on. So now that this transportation problem is said to be the balanced or the unbalanced depending upon this condition. We will calculate the sum of this and we will calculate the sum of this. If my total supply and my total demand, if both are equal, then we can say this is my balanced one. Otherwise, we will say it is a unbalanced. So once it is unbalanced, then there are the two cases. Either the demand is exceeds supply or supply exceeds the demand. So look at that. In this example, you can see the sum of this is my 30. Here is 60. So it means demand is more than of the supply. So this is called as the unbalanced transportation problem. So your always first task is to convert them into the balanced transportation problem. How you convert them? Since there is a need of the 30 supply, so I create a new row whose cost elements are 0 and the supply is 30. Now it's a balanced one. It's a 60 from here, 60 from this. So this is called as, we have added these 3, that is called as the dummy row. Okay. On the other hand, if my supply is greater than of the demand, look at in this case it is 100 and this is 60. So again this is my unbalanced. Then we have to add how much unit is 40, the difference of them 40 in this column. So this column is now called as the dummy column and this cost is computed by 100 minus 60. Now look at that, this on both sides is 100. Now it's a balanced one. So make sure that whenever you are working on the transportation problem, always convert the unbalanced problem into the balanced one by adding either dummy row or dummy column. So the important remark about the balanced transportation problem, once you convert the unbalanced into the balanced, so it always has a feasible solution. So these are remark about the balance. Total number of the variables are m and n. M is say number of the rows and n is my number of the columns. And then if you, since these are the feasible solutions, so how many we needed? That m plus n minus 1, and the non-basic variables are this. So if I say m plus n minus 1 are there, then again this is discretized into the two portion. One is the degenerate and second is the non-degenerate. If we computed such values called as the BFS, basic feasible solution, if it is less than of m plus n minus 1, we call as the degenerate. Otherwise we call as the non-degenerate. If you remember about your simplex method, when we say that the degenerate solution, if any of the basic variable is contained the 0 value in the simplex table, then we call as the degenerate solution. So look at that, what will happen if the values are less than of this? It means the remaining values are 0, so it means they are degenerate. So now based on this idea, we will design the MATLAB programming for this northwest corner method. So I can start with this one. You can simply write this in your MATLAB file. Look at that transportation problem, format short, clear all, and the CLC. Now I can try to explain the MATLAB programming for this arbitrary example. So look at that, what is that? This is 1456. These are my cost. So I can write this cost as first row 14, 56, 48, 27. There is no need to write dot 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 because in this case the space is very less, so I have write here. Otherwise you can write in this semicolon and the second row in the same line B. This A is my this supply. So since this is second row, so 13, 19 and 16. Now this is capital B, I denoted as this. This is a row and this is a column. So you can write this input information in your MATLAB file like this way. Okay. You can also write like this if you have the proper space. You can write like this. There is no problem about the cost value. So you can write the cost value here, this and so on. Similarly, if you want to write this, how you write that? This is the first row 517 semicolon. Second row is 646. Third row is 7325. And the row A, capital A is my 10, 80 and 15. Capital B is my 17, 25 and 30. Now the first step, you have to check that whether your problem is balanced or not. So if you think about this, so what is that? This is my balance. This is my balance problem. Look at that. If you check on the both side, this is my balance. On the other hand, if you want to check on this side, it is not balanced. Look at that. This is not balanced. So I will explain the first MATLAB code for this and then generalize that. So first task is to check whether it's a balanced or not. What is the condition for the balance is? The sum of this and the sum of this is same. I denoted this as a capital A, this as a capital B. So what is the condition for the sum is? If sum of A is equal to sum of B, then we call as the problem is my balanced. Otherwise, it is unbalanced. So this is the way. Now, if problem is my unbalanced, then what you do? You have to add the dummy row and column. So we will check whether the sum of A is less than of sum of B. So what will happen if I say this is my 15, for example, and so on. So if I say this is my transportation problem, the sum of this is my 35, and the sum of okay, I can say this is a sum of A and this is sum of B. So sum of B is greater than of A. Then what we do? We will add the dummy. Then we will add the dummy row. So what is the position of the dummy row is? At the end of this third row or at the end of the matrix B. So we can define the cost and plus 1, whatever the size of this, plus 1 to be the 0. And on the other hand, if my and the matrix, what is the element is there? Sum of B minus sum of A. So look at that. If I say this is 100, this is 40. So what is the dummy row we have added as a 0, 0, 0, 0, and the cost will be 100 minus 60, 40, that's a 60. On the other hand, if my sum of B is greater than less than sum of A, then we will add the column. Then you have to write, look at that, this is in the position of column and the values are same. And how you find the A of, so now instead of the A, now there's a B because you have to add here. So B of n plus 1 is this one. So this is the way you can check for the balance or unbalanced B. So if you want to see, I can run the file. Look at that. If I use this file here, so look at that. If I run the file, so firstly I will check that whether this is balanced or not. So I can see sum of A 105, sum of B 145. So it means this is not balanced. So what we do is we will make the code, we will check the balance or not. So I can copy the code from here and write in this position. Look at that. Check the balanced or not. So what you do is you can simply run the file. Now what will happen if I say, now look at that, the sum is, the given problem is unbalanced. So now A is here, B is here. So this is the dummy row we have added. Now once you are in the position of the dummy row balanced one, now we can start with the MATLAB code for this. So in this video I will explain you the two different methods for creating the MATLAB code for the northwest corner method. So let's start with the first method. So what is your target? Your target is to find the value corresponding to this. For example, here is 7, the remaining is 6. Similarly for the next one, this is my 6 and here is 8 and so on. So that value of x, 7, 6 and so on, I denoted as the x. So initially I set all are 0. How many basic variables are there? We can define the size, how many number of the rows and columns, and the total number of the BFS we needed, m plus n minus 1. Now in the northwest corner method, we always start with the disposition. What is the row is? This is the 1 comma 1. So I define I and j as the 1 and 1. I is for my row position, j is for my column position. And how many total BFS we needed is m plus n minus 1. So I define the variable as L, which is the BFS. So we will terminate the loop until my total BFS will L m plus n minus 1. So let's do with this one. So what we do is we will start with here. How you find that? We will compare this and this. So that is, this position is my AI, this is my B. So if AI is less than or equal to BJ, this, okay, so we will, what is I and J? So what is the value of here? I can assign Xij as minimum of 7 and 13. So how you write the minimum of this is AI Bj. So you can write like this way. But if you write this condition, AI is less than Bj, so this minimum is always be AI. So you can write this Xij is AI. So we will store the allocation here as 7. But in this case, Bj is not less than, so this condition is not fulfilled. So we will look at the else condition. If AI is greater than of the Bj, okay, look at that, AI is greater than Bj, then again, what is that? This is I comma j is the minimum is Bj. So once we are there, then what will happen? We will update the B, this might, because look at that, this is 7 and this is 13 minus 7. So 13 minus 7 is this minus this. Then we will update the row, because if we are say for example this is 7 and this is here. So what will happen? So this is 7 and this will be 6. So we will, this is my position 7. Now the second one is a 6 here. We will start from here, that is the second row. So we will update the row as this. And since we find the one BFS, so we will count the BFS as this. Otherwise, now look at this example, this case. Look at this, in this example, which one satisfied? A is greater than of the B. So this condition satisfied. So what will happen? We will assign here, what is the position is? Minimum of this, minimum of A and B. So if this condition hold, what is the minimum is? B. So the value of here is 7. So what we do is, in the next phase is, now this will cancel out. This will be 6. How you compute 6 is the previous value of A minus the value of this. So that is the value is B. A minus B. So this is here. Now in the next phase, you are moving here. The next iteration come at here. So this is J. This is J is 1. Now this is J is 2. So we will update as J is J plus 1. Counter BFS as L plus 1. Now otherwise we will break. So this is the method 1. Look at that. If you are moving here, so for example, if in the first case this will be 7, now 6, now here is 6. Now in this case we will move on the second row. So second row means I will be counter. If you are moving on the row column wise, then the J will be counter. So this is the simple method 1. Now what is the method 2? So the method 2 is quite easy. Now instead of writing all these commands, you can instead of this, you can simply write here x is 0 and m is the size. So you can start with the 2 loops. Firstly, we find the minimum of this. Minimum of AI Bj is I call as the x11 position of this. Then we will update the AI. We will store the value of x here. Then AI is my A minus, what is that? If I use as a 7, we can subtract 7 from here. We can subtract 7 from here. So we can subtract A as A minus x11, B from the B minus x11. And then we will end the loop for here. So this is the simple method 2. Okay, so in both the cases you will get the updated solution. So look at that. If I just write all this here, like if I write the code from this, look at that. If I, this is the method 1, if I just copy this method 1, I can write here the method 1 simply. Now what you do, now if you want to print the solution, so look at that, how you print the solution. So solution is stored in the form of the capital X. So I display the capital X here. Look at that. The meaning of this is, what is the meaning of this? Okay, I think I solved the example 2. So if I want to solve the example 1, so now look at that. The example 1 is my balance problem. Look at this example is my balance problem. So what you do in the first case, this is 7, this is 6. So look at that, output are there 7, 6, and the rest row are 0. What is the meaning of 0, 8, 11, 0? It means once you solve this, this will be my 8, this will be 11, and rest 0. And the last one is 10 and 6. So once you solve this problem, you will get 10 and here as a 6. So since all the values are stored in the capital X, so I use the array to table capital X of the IB, initial BFS. So look at that, this is the printing solution. Now what you want to do, now since you find the initial BFS, now you want to check whether they are degenerate or non-degenerate. How you check that it's a degenerate or non-degenerate? You will calculate this BFS. If this is equal to m plus n minus 1, then they are non-degenerate, otherwise degenerate. So we will find the counting. How you find the count is total BFS. You will calculate the length of the non-zero x. So look at that. What is the meaning of the length non-zero x? If I just write here length of the x, these are my x. These are all my x. So it gives you 4. But how? So I can write. So look at that. X is my this. So length of non-zero x. So what is a non-zero x? So if you look at this, how many non-zeros are there? 1, 2, 3, 4, 5, 6. So look at that. Length of the non-zero x is 6. So what is the meaning of this? This is my nothing but m plus n minus 1. So this is my total BFS. I will check this total BFS. If this is equal to, I initially define the BFS as m plus n minus 1. Look at the MATLAB file. I define the BFS as here m plus n minus 1. If my total BFS is equal to this, then I can say the initial solution is non-degenerate. Otherwise, we will call as the degenerate solution. So like, look at this. If I just write the file, if I just want to print the solution, okay, so look at that. So if I run the file, now once you will get the x here, then how you find the cost? So you finally you want to find the cost. So look at that, this is 7, this is 6. So how you find the BFS cost? 14 multiplied by 7 plus 56 multiplied by 6. This is now my 8 plus 35 multiplied by 8 and so on. So it means this 1482 I just denoted in the form of the cost. 768 is stored in the form of the x. So I can multiply this. Look at that. This is my initial cost value. This is a capital X allocation. So we can multiply this. So it will be there. Now if you want to find the sum of the cost into x, so it will give you this. That is a column wise. But if you want to write sum in the 2 times, it will you firstly print. It will give you the firstly this part will give you the answer of this, and this sum will give you the total answer of this. So look at that. If I want to find the compute the cost, so this is the initial cost of this. So you will get the printing solution. So look at, if I run the file complete. So if you want to see, this is there. So the given transportation is problem is balanced. This is the original. The initial BFS is non-degenerate, and this is the simple MATLAB code. So if you want to run the second example, so what you can do is you can simply comment on these 3 lines and run the second example. Now if I run the file, this problem is my unbalanced problem. Okay, so this is there. The answer is 5, 6, and again it is a non-degenerate solution. So if you want to, this is the end of the code, and this is a simple procedure, you can follow this. If you want to compare the performance of this transportation code with the other algorithms, graphical method, simplex, BFS, two-phase, dual simplex, so you can simply click on this link. You can find the more videos. So you can see this is the simplest MATLAB code. If I just magnify it, always you need to change the first 3 lines. Rest the code will be same as such. No, there is no need to change anything in the rest of this. So this is checking the balance or unbalanced. Once you will check the balance and unbalance, then you will set there are the 2 methods. First method is this. Okay. Second method is, instead of this, you can simply write these lines are there. You can simply write this 4 lines instead of this. You can delete this. You can delete the code from here. This, instead of writing here complete, you can write that code. So if still there is any doubt, you can contact me or you can browse this link for more updates. Best of luck, students. Happy learning.